capillary tube, you're not going to see these very often. Okay, this is something that would be on window units. It is a metering device in the fact that it's a small tube with a very small opening. So we're going to get our metering effect by the length of the tube and the diameter of the tube. Not going to be a house AC thing. It's going to be window units, small things, refrigerators. So we're not going to be dealing with these a lot. We'll put that aside. We're mainly going to be dealing with fixed orifices and thermostatic expansion valves. So here's a thermostatic expansion valve that you might find on today's system. And this one here has these screw fittings on the side, which is really nice. If we turn this guy around and look, we can see we've got the male fitting here with the Teflon seal. We've got the female fitting on this side, which is nice. We've got our bulb here. It's going to mount on our suction line, and we're going to secure that, and we're going to insulate that. And then we've got what they call an external equalizer connection right here. So there's a lot of things going on in a thermostatic expansion valve, but it's not that complicated when we think about what it replaces. Okay, so when we buy a system and it doesn't have a TXV, the thermostatic expansion valve, it usually has this guy. It has the fixed orifice. So at its most basic form, it's the same male, female fitting. The difference is it has these little pistons. There are various sizes of these pistons. We buy these pistons based on the hole size. Okay, that hole size is given to us in thousandths of an inch. The manufacturer will tell us what size piston goes with what size unit. The piston slides in, the pieces screw together. As the refrigerant flows in here, it's got to go through that small piston. That hole size determines the size of the system, the tonnage. So it's fairly simple. If something changes, we just simply change the piston. Pretty easy. Now, here's the thing about the piston. It can't do anything by itself. So if the load changes on the unit, say it gets hotter outside or colder outside, or the load inside, the humidity goes up, this is still doing the same job. It's still that big, whatever that is. That's where the expansion valve comes in. When we take our expansion valve, what I want you to notice is this fitting, the way this fitting fit together. If I simply open that fitting up, take the piston out, look how easy it is to put an expansion valve in its place. Okay, very simple, almost so simple there's no reason not to do it. All right, so an expansion valve itself would mount in an existing fitting in most cases. The bulb would get clamped onto the suction line in the 10 or 2 o'clock position. Whatever the manufacturer tells you to do, we're always going to follow manufacturer's instructions. When you open the expansion valve, those instructions are in there. So we're going to follow those. We're going to then take a look inside here. I've got one that's cut open. We can kind of look in here and we can see that it's got a pin, a tapered pin, and as this bulb warms up or cools down, it's going to put pressure on the bellows, going to put pressure on the pin. It's going to move that pin up or down. Okay, when that pin moves, the size of our hole is going to change. When the size of the hole change, we're able to adapt to the load of the system. This is what makes expansion valves so nice. Okay, they're highly adaptable to the load, and they change all the time. They literally cycle up and down all the time. So we charge a unit by subcooling method if we have an expansion valve, a much simpler method to charge by than a fixed orifice. Fixed orifices we have to charge by superheat. Superheat's based on all sorts of wet bulb, outdoor temperatures. We can eliminate that by going to an expansion valve. Now, what if an expansion valve power head fails? Or what if we have an expansion valve that's an R22 expansion valve? We want to convert the system to 410. Sometimes we can reuse the expansion valve simply by replacing the power head. Some of them unscrew. We can put the proper one. This one happens to be R22. See the green on it. That's not always the case. Don't rely on it. Look right here at this one again. This bellows is not removable on this one, so it couldn't be removed. Now, to finish up on metering devices just a little bit, what I have here is just a needle valve. This would be a high pressure needle valve that you might find in hydraulic applications. If I put this in place of any of these this fixed orifice or the expansion valve, it will work. Okay, I'm not recommending you to do it, but I'm strictly explaining how simple a metering device is. If I started out with this closed, I opened it up a turn or two, I started checking superheat and subcooling, I dialed the system in to a perfect amount, it would be a perfect fixed orifice and it would work very well. I would still recommend you go back with this, but know this, all a metering device is, it's just that, it's a metering device. It meters liquid refrigerant through a tiny orifice. If it's a fixed orifice, it's not adjustable unless you replace orifices. If it's a thermostatic expansion valve, it adjusts itself from one end of the scale to the other. That's mainly all you need to know about these metering devices that we use.